This lecture is lecture 14, the viscous flow in the pipe, part 2. The first topic is fully developed turbulent flow. Turbulent pipe flow is more likely to occur than the laminar flow in the practical situation. Turbulent is very complex process. In this lecture, we can provide only some very basic idea concerning turbulent. From previous lecture, to visualize you what is the difference between laminar flow and turbulent flow, I will show you the clips about. Okay. This clip shows that the dye the water at the left hand side, and to see what happens if the velocity of the flow increase or the flow rate of the flow increase. You can see that the stake line is the smooth. Once the increase the velocity and discharge, you can see the fluctuation of the velocity along the pipe line, and that is the the turbulent fluctuation. Okay, for change from laminar flow to turbulent flow. Okay. The other case is similar. This is like the fluctuation of the velocity. We call it intermittent turbulent burst in the pipe flow. Okay, turbulent burst. Another case is compared between laminar diffusion and turbulent diffusion, between smooth flow and the fluctuation of the flow for the turbulent diffusion. Okay, you get some idea what is the difference between laminar flow and turbulent flow. For the turbulent, for the transition from laminar to turbulent, we use Reynolds number to classify if the rate length 2100 is laminar, greater than 4000 is turbulent. Okay. If we consider a long section of the pipe to start to flow, velocity and Reynolds number increase from 0 to no flow to the maximum steady state of flow, shown in this below figure. Typical axial components of the velocity measured at the given location. So this one we measure this point at point A. We measure the velocity and velocity change with time. Okay, and we can see that if once we increase the time increase and velocity increase, you can see that from laminar to turbulent flow there is a fluctuation of velocity on the way once the velocity increase. Between laminar and turbulent is the transition. This we call the turbulent burst, fluctuation of the velocity, or we call the random turbulent fluctuation. And for the irregular random nature, the pressure drop and heat transfer occur depending on the turbulent fluctuation or randomness. Okay, that is the expansion of the turbulent fluctuation on this figure 14.2. We can explain that for the turbulent flow is chaotic random behavior for 3D of velocity, pressure, and shear stress and temperature. So we can characterize by random 3D vorticity. Flow can be described in terms of their mean value. Okay. In this case, we want to find the mean. So each time mean value of is u bar is the mean. We can take the average of u bar and divide it by t. T is the duration of we consider d. Okay, and this is u is function of t, and this is the u bar is the fluctuation and the u palm, okay, and u bar is the time average for the mean value, okay, for u bar. So this one, if we take the average of u with time, we can get u bar. And for u prime is the fluctuation part of the velocity, and for u at any time is equal to u bar plus the u prime. U anytime equal to u bar or mean plus the fluctuation or u prime, okay. And we can find the integration for average of u prime is equal to the difference between u and u bar, okay. And if you expand the equation into two terms, okay, we're going to find that the average is going to be 0 for the average of the fluctuation part, okay. So in this case, you can see that this the hash line for u bar prime is going to be 0 because it's plus and minus, and it will be cancelled to 0. So in order to see clearly what is the fluctuation, so we use another way that we use the u bar power 2 and before we take the average, okay. And this one we u prime u bar the power 2 and integration between t naught plus 3. So we're going to have like this line, the dash line, the u prime square. So that is the average of u prime square. So it's greater than 0, okay, for to see clearly what is the fluctuation of the velocity. And for to represent to find the turbulent intensity, we use this term u prime square root divided by u bar, okay. Larger turbulent intensity, the larger the fluctuation of the velocity. For laminar flow is modeled as a fluid particle that flow smoothly. For the laminar flow smooth along the layer. So we can explain by using this equation for the shear stress is a function of the velocity gradient, but for turbulent flow we replace u with the u bar, so this not equal, and consisting of the tree of the random tree eddy type. You can see that is the turbulent eddy for the turbulent flow in the right hand side.